Hello Mandela class, welcome back to your maths videos. I hope you all had a great weekend. Today's learning objective in maths is, can I use known multiplication facts to solve other multiplication problems? Okay, so the first thing for you guys to discuss is, to pause the video and discuss, or have a think about, is what is the same and what is different about these two piles of money? So pause the video and have a think. When you're ready to discuss, then play the video again. Okay, so did you notice what was the same about the two piles of money? Well, if we count carefully, we will count it together. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So there are 14 coins here. And how many coins are in this pile? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There are also 14 coins in this pile. So that's what's the same about between these two piles of money. They both have 14 coins in them. Now, did you spot the difference between the two piles of money? What was different about them? Well, if we look carefully, these coins represent 1p coins, and these coins are 10p coins. So one pile is made up of 14 1p coins, 1p coins, and another pile is made up of 14 10p coins. Okay, now I want you to think about how you could represent the value in each of these piles. How could we calculate the total value given that these coins are 1p coins and these coins are 10p coins? How could we calculate the value of each pile? Now remember, there are 14 in each pile. So how could we calculate the value? Well, one way could be that we just count the coins given the value that they have. So we know that in this pile, the coins have a value of 1p. So 1 penny. So what we could do is just count it in ones to see how many there are altogether, how much money there is altogether. Well, each coin represents 1 penny. So 1, and we already know that there are 14 coins, so we don't really need to count it again. So 14 coins, each with the value of 1 penny, gives us 14p in total. But here, how would we count? Because the value of the coins have changed. The value of the coins is now 10p per coin. So what's changed and how could we count it? Well, we could count it in tens. So let's count together. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, 140. So here we have got 140 altogether. If I was to ask you, based on the value of each coin, so here the value of the coin is 1 penny, and here the value of the coin is 10p. Based on the value of the coins, could you write a multiplication number sentence to find the value of the whole pile? Pause the video and have a think. Okay, so we already know the value. We calculated it. We've counted it. We want to do it a different way now. So we already know that the value of each coin in this pile is 1p.
earlier in tens. So we know that 10 times 14 equals 140. Now pause the video. What do you notice between this answer, 1 times 14, and this answer, 10 times 14? So if you look very carefully, here we have got 14, the two digits. Here we also have the same digits but with an extra 0. Why do we have that extra 0? Because we are multiplying this number, we multiplied it by 10, whereas here we've multiplied it by 1. So is there a rule that you can come up with when multiplying a number by 10 compared to if you were to multiply it by 1? Well, if we multiply one number by 1 and we multiply the same number by 10, all we would need to do is add a 0 to the answer. Okay, so here it's very similar to what we've just done. Can you pause the video and complete the multiplication fact? So look at the value of each counter and look at how many counters you've got altogether to give you the answer. And here look at the value of each counter and then how many counters you've got altogether to give you the answer. Okay, so let's look at how many counters you've got altogether. Let's count in two. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. So we've got 24 counters altogether. What's the value of each counter? 1. So 1 times 24, because one counter has been repeated 24 times. So what's 1 times 24? 24. Okay, here, what's the value of each counter? 10. And how many counters do we have? 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. We also have 24 in this file. Now remember what we discussed in the previous slide. If a number is being multiplied by 1, what happens to the answer if that same number is being multiplied by 10? So how could I use this calculation, the first calculation, to help me with the second calculation? Well, the same number is now being multiplied by 10. So what would I need to do to this answer to then get this answer? Well, when the number is being multiplied by 10, all we need to do is add a 0 at the end. So we've already calculated 1 times 24, which equals 24. Now we're multiplying it by 10, so we need to add a 0 at the end. 10 times 24 equals 240. Okay. If we know that 3 times 4 equals 12, we also know, so here's the 1 that my number is being multiplied by. Now the same number is being multiplied by 10. So if I know that 3 times 4 equals 12, I also know that 3 times 40 equals 120. These numbers are the same. These numbers are the same, but it's just got an extra 0, so my answer will have an extra 0. Now, if I know that 3 times 40 equals 120, can you use this to complete the fact family? Can you write another multiplication number sentence and 2
Okay, so we know that multiplication is commutative. So we can use that to help us write another multiplication number sentence using these numbers. So if 3 times 40 equals 120, using the commutativity law, 40 times 3 also equals 120, because if you remember, if we swap the numbers around, the answer will not change. Pause the video and have a think. What's one rule that we must follow when dividing? Sorry. Well, we always must start with the largest number, just like in subtraction. Otherwise, we won't have enough. What's the largest number in this number sentence? 120. So we must start our division with the largest number. 120 divided by 40 equals 3. And another division number sentence, again starting with the largest number. 120 divided by 3 this time equals 40. Okay, so now I've got my fact family, my 2 multiplication number sentences and my 2 division number sentences. Okay, now what you're going to do is your independent task based on everything that we have just learnt. The main thing I want you to focus on is the fact that if a number is being multiplied by ones and the same number is then being multiplied by tens, all we need to do is add a 0 to our answer. So for example, if we have got 2 times 5 equals 10, 2 times 50 would equal 100. All we've done is add a 0 to the 10. So read these questions really carefully, wherever it's asking you to show your fact family as well. So this question number 4, you're going to have to write another. If it's a multiplication number sentence, you're going to write another multiplication number sentence and 2 division number sentences. And if you've got a division number sentence, you're going to write another division number sentence and 2 multiplication number sentences. So altogether, you should have, for each of these, you should have 2 multiplication number sentences and 2 division number sentences altogether. Let's quickly talk through these. The number pieces represent 5 times, or how many holes are there in each of these shapes? 1, 2, 3. If each hole, so you would complete that based on how many holes there are, or how many circles you can see. Then it's saying if each hole is worth 10. So once you've represented this as a number sentence, then you pretend like each hole represents 10 rather than 1. And similarly in this question, you do the same. Okay, I look forward to seeing all of your work on Tapestry. Well done for working so hard at home, and I can see that lots and lots of you are uploading your work. So well done, keep it up, and I will see you in the next video. Bye, Mandela class.